Weight is a word that we throw around in everyday life all the time. We weigh ourselves, we weigh objects around us. But if you were to ask someone what weight is, someone may tell you, it's how heavy an object is. And while that's not completely wrong, it's not exactly the right answer. Instead, weight is actually a force. So every object on Earth right now is pushing down towards the ground with a certain force at any given point in time. That force is measured as weight. So in the standard unit system, force is measured in pounds. And I'm sure most of you use pounds in everyday life, especially when we weigh ourselves. However, we will be using the metric system. And the metric unit for force is actually going to be newtons. Now, what a lot of you may know is that if you were to go to a different planet right now, you would weigh a different amount. The reason for this can actually be explained with this equation on screen. Your weight, also called the force due to gravity, is equal to your mass times the acceleration of gravity on any given planet. Now, the acceleration due to gravity is going to be how fast an object will accelerate or speed up when dropped. Now, the first thing to point out about this equation is that your mass will never change based on what planet you're on or where you are. What many people get confused is that mass and weight are completely different things. While weight may change depending on where you are, the mass of an object is actually the amount of matter within it. So no matter what planet you're on or where you are, your mass will not change. However, the acceleration of gravity will change based on what planet you're on, and that's what's going to change your weight. So for example, our moon has a smaller acceleration due to gravity than our Earth. This is why astronauts weigh less on the moon. So let's go through an example. So let's say that a mass of an object is 20 kilograms, and let's also say that that object is sitting here on Earth, where we have an acceleration due to gravity of 9.8 meters per second squared. If we pull up the equation that we just had on screen, we can find that the weight of this object, or the force due to gravity, is equal to the mass times the acceleration of gravity. Therefore, the weight of this object is 20 times 9.8, or 196 newtons, which translates to about 44 pounds. So this shows that if a planet has a different acceleration due to gravity than Earth, then you will weigh a different amount on that planet.